So this is section 6.2, and it's applications of normal distributions. The cool thing about this section is it's really going to help us to understand the last section a little bit better, because now we get to actually apply it, and we're just doing more of the last section. We're just doing it in terms of applications. So the standard normal distribution curve can be used to solve a wide variety of practical problems, which we'll be doing today. The only requirement is that the variable be normally or approximately normally distributed. For all the problems presented in this chapter, you can just assume that the variable is normally or approximately normally distributed. And so you don't have to worry about like, oh, is this going to work for this problem? Like, we promise that in this section, it is going to be normally distributed. So you don't have to worry about that. And we're going to go ahead and get started. And then the other thing I want to tell you right off the bat is there is a complicated way to do these problems, and there is an easy way to do these problems. I'm going to show you the complicated way first, because that's kind of like what my little filled in notes say to do. But I'm totally going to show you the easier way as well, because the easier way, I think, is actually kind of cool. And I was really excited that I discovered it with our calculator, which we have to use calculator anyways. We might as well use it the cool way. Okay, so just a reminder about z-scores. To find the z-score, you can do the specific value minus the average, and then you just divide it by the standard deviation. We write it in this format over here, where we have the specific outcome minus the average over the standard deviation. So that just is a reminder of z-scores. And we have this first example that we're going to do together. I'm going to show you two ways to do this, and then we'll go into your homework, because like I said, the notes kind of go off on a tangent versus your homework. So an adult has an average of 5.2 liters of blood. Assume the variable is normally distributed, which we get to do in this whole section, and has a standard deviation of 0.3. Find the percentage of people who have less than 5.4 liters of blood in their system. Okay. So the first thing I want to point out is that you're going to see it written as the probability of X less than 5.4. So this is like one way they can write the same question. And the reason why it's less than is because it's asking us to find less than 5.4. So you're going to kind of see that notation in your homework. And as you saw on our warm-up, this line here represents our average, and this number is, in this case, it's representing what we're trying to find to the left. So we're trying to find that area which would give us the probability. The standard deviation is 0.3. So what we're able to do is we're able to actually transform our specific data into our normal distribution here. And so what we can do, and we can do this with all data that is normally distributed, we can turn our average into 0, and we can turn our 5.4 into a z-score. Okay, so this is how you do that. I'm going to show you how to do that. So, like I said, this one represents the original information or data. We can standardize it. So to standardize, we will find the z-score. Okay, so to find the z-score, we're going to use that formula that we just talked about, all right? So let me rewrite that for you. It's going to be the outcome minus the average over the standard deviation. All right, well, our outcome over here is 5.4. So x is equal to 5.4. Our average, so remember this symbol just means the mean or the average, is 5.2 over our standard deviation, which is 0.3. So they had to give us, so this information they gave us, the 5.2 and the 0.3, we are using in our formula. That's going to help us get the z-score. So they have to give us that information. That will allow us to find the z-score. And so if you type this part into your calculator to get the z-score, so we're just comparing that outcome to the average and we're dividing it by the standard deviation, our z-score will be approximately 0.67. And that's what we have right here. Okay, so what we can do from here is to find the probability of x is less than 5.4. We can actually use the 0.67. We can use that z-score. And so we can do our normal CDF. And then because it's to the left, now the reason why I know it's to the left is because it's actually, they already drew a picture for me, but this less than implies negative infinity. So remember, negative infinity is like way over here on our graph, but our calculator we can't handle negative infinity. Now, some of you can put that -1 E99 into your calculator, depending on which calculator you have. I cannot do that. My calculator doesn't let me do that. So if you're using the same calculator as me, I'm going to be a little bit crazy here, and I'm going to actually type in -9999999, like just a ridiculously small number, negative number, right? Trying to imply negative infinity. And then I'm going to go to 0.67. So this would be my lower, and then this next one would be my upper. And I'm going to show you this with our calculator. All right, so for our other method, we can still use normal CDF. But if you look at what your calculator is saying, when you do the normal CDF, you have lower, upper, and you have the average, and you have the standard deviation, right? Like it kind of tells you to do that, even if it's in a vertical format. So my lower is -9999999, or you're using -1 E99 on your calculator if your calculator allows you to use that E key. Mine does not. The upper is, this time, we're going to actually use the value 5.4. So the upper, we're going to use the actual value instead of the z-score. So we're going to use the actual value. We're then going to use the average. So the average or the mean was given at the beginning. It's 5.2. And we can use the standard deviation, which is 0.3. Okay, so I can convert the 5.4 to a z-score, or I can use the raw data. Okay, now I'm going to show you how that would look in my calculator, and you can follow along depending on, which calculator you're using, because I think that's the only thing about teaching this via Zoom is it's hard for me to go around and help people with their calculators. Some of you might be using an Inspire, some of you are using the same one I'm using, some of you are using a TI-84. So the TI-84 might be vertically aligned, but you can still type in that information. So let me slide mine back over to where you can see it. Okay, and I'm going to do the same thing. I'm going to do second distribution, normal, but this time my lower, I'm going to do -99999, several nines, it should be fine. And then I'm going to do 5.4, comma, this time I'm going to do 5.2, comma, and then I'm going to do 0.3, which is my standard deviation. So what I've done is I'm just putting in the data completely the way it is, and you can see we get something very similar to what we had. In fact, the rounding can become a little bit interesting because the rounding, well, we rounded here for our z-score, and so this one is actually not going to be as accurate as the one we just did. But there is a tolerance in ALEKS where it should accept either one. Does that make sense? And you'll see that, you should see that as you're doing your assignments. Maybe you try both methods and they should both be accepted. But either way, we end up with about 0.75, which would be 75%. Are there any questions on that example? Okay. So then what we'll do is I'm going to start kind of going through some of the homework problems to practice this. We're going to do several together. And then there's one question that you're going to see on your homework that it's like not in the notes at all. And then there's a part of your notes that's not in the homework. It's